Alright, today we will continue to look at the content of H3A Cloud Computing. Next, we will mainly look at the overall development process of cloud computing. Previously, we have generally introduced the basic characteristics of cloud computing, so now we will focus on its development. So, what does the cloud computing we use now look like? First of all, in the beginning, our cloud computing is mainly divided into 3 stages. 1.0 to 3.0. Initially, actually. The beginning of cloud computing roughly started in the 21st century. Before that, there was basically none, as virtualization hadn't developed much and hasn't been around for many years. Here, the main development began with a large-scale application of virtualization. The standard virtualization we commonly use now, for example in Windows, the default is Hyper-V, including Xen, and in Linux, we mainly use KVM and ESXi among others. These are some of the commonly used types of virtualization. As we mentioned before, our cloud computing is actually built on virtualization, so this is essentially a basic aspect. After virtualization crystallized, our computing gradually started to become popular. In this area, we generally use virtualization technologies like VMware, Xen, and KVM to partition our physical resources. And then, integration. Hyper-V is a virtualization platform from Microsoft. Generally, in server environments, Windows systems are used less frequently now, with Linux being the primary choice. Therefore, Hyper-V is basically not used anymore. The focus is mainly on the following types of virtualization. Its main core value, which is also the core value of our virtualization, is actually to enhance the resource utilization rate of our servers. How much can it be improved? In fact, before informatization, the utilization rate of many servers was not very high. It might only be around 10%, 15%, or 20%. After virtualization, we can directly increase the server utilization rate to 70%. Of course, it can be higher, but if it's higher, it becomes relatively less secure, right? So generally, we aim to increase the server utilization rate to about 71%, and the remaining 30% is used for redundancy to handle unexpected situations. This is one of our strategies. Virtualization is a key component for our overall cloud computing strategy. Here's a specific example. A bank used virtualization technology to consolidate 100 servers into 10 and reduce their operational costs by 60%. So with virtualization, our resource utilization can be greatly improved, which means that both in terms of financial investment and the overall difficulty of operations and maintenance, there will be a significant reduction. This is one of the benefits. Virtualization provides an overall benefit to cloud computing. Next, let's look at the second phase, which spans from 2010 to 2015. In the previous phase, virtualization was just emerging, and we were building some aspects of cloud computing on the foundation of virtualization. Starting from 2010, what officially began was true cloud computing, which is what we commonly refer to as cloud computing today. At that time, the open source cloud platform OpenStack emerged. It supports the flexible construction of our private cloud. Additionally, public clouds also began to increase gradually from this time. Initially, who was doing the most? Actually, in our country, there wasn't much happening. Domestically, there really wasn't any. The largest at the beginning was actually Amazon Cloud from abroad. Amazon Cloud. Amazon introduced services like EC2, S3, and others. These cloud services, such as cloud servers and cloud storage, were initially launched by Amazon Cloud. Afterwards, Amazon Cloud essentially led the commercialization of all public clouds. In the realm of public clouds, Amazon Cloud took the lead, starting from 2015. Starting from 2016. Some domestic cloud platforms gradually began to develop. Before that, mainly between 2010 and 2015, Amazon was more active in this area. In terms of public clouds and private clouds, due to the emergence of this technology, many companies started to engage in this. Of course, generally, small enterprises don't have much funding to do this. To begin with, you need to have some servers, and the number can't be too small. If you are familiar with too few quantities, actually. it's not possible to create a relatively large platform. So generally, medium-sized enterprises or some large enterprises can do some things themselves, like building a private cloud platform through this, which can be implemented within the internal network of their own enterprise to achieve cloud computing. With a private cloud, there's no need for anything, and you don't need to purchase from a public cloud. Generally, the public cloud has a large share. Most of the customers are actually what? Actually, many are. More small and medium-sized enterprises. Generally, large enterprises have a lot of equipment themselves, so we can set it up ourselves, and there's no need for anything else, no need to purchase from the public cloud. If we set it up ourselves, right, we can directly use our own hardware to install and deploy our virtualization platform, and then we then manage our virtualization platform as a whole. With virtualization, the underlying layer is generally software. Managing virtualization software itself is not that convenient, so we usually add our own management layer on top of the virtualization software. Add something like this. A management platform to manage all our virtual machines and all our resources, like this. After 2015, by this time, container technology has also developed quite well containers, including our own. Some container management platforms have gradually grown and expanded. For example, K8s, which is a service of Kubernetes, a container management platform, and also includes various other microservices, and so on. Content, various software platforms from 2015 onwards, have sprung up like mushrooms after the rain, gradually developing. Actually, from this time onwards, there has been more and more software, and the services needed have also increased. And subsequently, how do we achieve this? Through containers, we can achieve lightweight encapsulation. This actually serves as a second push for the overall computing, as we mentioned earlier, in 2010. The private cloud platform and public cloud platform were actually the first push, and the second push is our containerization. After containerization, on many of our cloud platforms, what appeared? Previously, many were mainly based on our regular, ordinary cloud servers. Subsequently, besides ordinary cloud servers, starting from 2015, what else appeared? A large number of cloud containers appeared, including cloud management platforms, which is our cloud native. Overall, this led to a restructuring of our entire cloud computing business. Here, actually, first of all, previously, for example, our human bodies, let's say a public cloud platform. Usage for users, generally speaking. The main function is to achieve dynamic resource scheduling, such as elastic scaling, supporting the surge in our internet business, for example, during holidays, flights, and festivals. There are some specific. With some business growth, elastic scaling can be achieved, making it more convenient, After containerization, it can basically achieve second level scaling, meaning expansion can be realized in just 1 second. Moreover, the self-utilization rate can naturally reach over 90%. Here you actually don't need to worry too much about resources being maxed out. Why? Because as soon as your resources are full, or about to be full to be precise, if the resources are about to be full, we will immediately initiate elastic scaling. And at the speed of 1 second, we can create many, dozens, or even hundreds of containers to help us expand the overall business. This is the second boost to our budget after the introduction of containers. In terms of overall development, actually everything from the very beginning of simple virtualization to a comprehensive public and private cloud management platform to finally adding containers and cloud-native solutions. The development of budgeting, overall, currently mainly involves extensively using containers in both our public and private clouds. This includes utilizing our container management platforms to manage everything comprehensively. The main advantage is that it allows our business to iterate quickly, expand rapidly, and greatly improve our resource utilization efficiency. This is the overall development process of our cloud computing. Alright, that's all for today's content. To learn about Huawei's cognitive technology or to obtain Huawei's question bank, please send a private message. You can also leave comments below the video for technical exchanges. That's it for today, everyone.